Hi guys, welcome back to another fun day of math. So let's do this. So today we're going to talk about the infamous object thrown in the air problem. So pretty much this is how it's going to go down. We're going to take an object, namely I guess a ball. We're going to take it from the ground and then you guessed it, throw it up into the air. Just like that. Cool. Yeah, that didn't work out so well. It worked out better in my test run. So let's do this. So the problem reads, if an object is projected upward into the air from ground level, then the height h of t of the object in feet at time t in seconds is given by this. Okay, so we have a fun little question, but check it out. Before I read it, I need to have a clear idea of what t and what function h represents. I don't have to define anything, but there's something about me writing it that kind of helps to delineate. Okay, t represents this, h represents that. Okay, let's go ahead and do this. Okay, so from the top, if an object is projected upward into the air from ground level, then the height h of t, I'm gonna stop right there. Okay, so now they're telling me what function h represents. Okay, so h of t represents height. So we have h of t represents height. Okay, height of what? Height of the object in feet at something. Okay, so it's the height of the object and the units are in terms of feet. Cool. Okay, that's nice. So thanks to our detective skills or our reading skills, we know what the function h represents. Now it's important if we know what t represents. Okay, then the height h of t of the object in feet at time t in seconds. So what's so special about t? It represents time and the units are seconds. So we have t equals time and the units are seconds. Notice that we did not introduce t, we did not introduce the function h, so we don't have to define anything. But in order for me to have a fair shot to answer this, I need to have a clear idea of what t and function h represents. So it's like, what does t represent? Oh, the time in seconds. What does h represent? Oh, the height in feet. Cool, let's do this. Now with that clear, let's go ahead and answer the first problem. So today we're going to do two sets of problems, so two fun problems, and then we're good to go. So the question reads, how long does it take for the object to hit the ground? Okay, I have no idea. Okay, I know you're like a total smarty pants because I can't say other words. So you're total smarty pants. So you can probably go straight to attack mode, but for me it's very difficult. So I'm gonna write down my thought process. How long does it take? Okay, how long? They're asking me for time. So time, which is given by t. How long? No idea. Whenever possible, I like to paraphrase the problems. That's the only way I can break it down. How long does it take for the object to hit the ground? Okay, object hit the ground. So we are talking about the height. Okay, so my Play-Doh fell off. Okay, so I get a ball, I toss it in the air, and then it comes back down. Okay, when it hits the ground, what's the height of the object? Well, if it's on the ground, then the height of the object is given by 0. Okay, so find the time when the height equals 0. Okay, so like all problems aside, what this boils down to is find t when h of t equals 0. So I'm giving a nifty function to find the that illustrates the height of the object at any given time. Let me go ahead and start out with the function. I'm going to write it out and then plug in what I can and then solve for whatever I need to. Okay, so we know that h of t equals 0, so the height equals 0. We bring down the rest of the problem. Okay, height equals 0, and then we want to find t. Okay, so words aside, let's go ahead and do this. So how should we solve it? For now, together, so what kind of equation is this? This is a degree 2 equation or quadratic equation. So we're going to solve it by factoring. So in order for us to solve a quadratic equation by factoring, the first step we need to do is set it equal to 0. The next step is to factor completely. Prerequisite step is to watch out for common factors. Now I know you're a genius. You're like, oh, GCF between these two terms is this. okay? But I really don't know what the GCF is. So I'm going to go ahead, bust out a ladder, reference to our earlier problem, but just write down the coefficients. And then I'm going to go ahead, use the ladder to find the GCF. I'm going to divide by the first number that comes to mind. These numbers are out of my zone, so they're both even, so I'm just going to divide by 2 a bunch of times. When we divide by 2, 2 goes into 16 8 times, and into 1332, 6 times. Let's get rid of that quick. 8 and 6 have a common factor of, I can't even say that number, have a common factor of 2. And when we divide, 2 goes into 8 4 times, and into 6 3 times. I mean 3 times. That's how nervous I am. Okay, remind me to scratch this problem. Okay. Our leftovers don't have any factors in common other than 1, and the GCF is given by the product of all the numbers to the left, so namely 4. Okay, so for the coefficients, the GCF, where am I? It's 4. For the variable terms, the terms have t squared t have 1t in common. Okay, now I don't really care if you factor out a positive 4t and the negative 4t, but you know my speech. Whenever you take out or factor out a common factor, it's always nice if we start on a positive note. Who cares if the rest of the terms are negative? So for that reason, for my peace of mind, we're going to factor out a negative 4t. So let's do this. First term over common factor, that will leave us with 4t. Second term over common factor, the quotient according to our ladder, 1332 divided by 4 gives us 333. Okay, so that will leave us with negative 333, but you could punch it in. Cool, so now we have begun to factor. Now the question is, can we factor more? The degree is 1 of the resulting binomial, so we know that we cannot break it down. So we got a lucky break that just by taking out the common factor, we are done factoring. So let's do this. When it comes to solving quadratic equations by factoring, step 1, set the equation equal to 0. It already was. Step 2, factor completely. And step 3, apply the zero factor property. Now, on the paper, I know that we have 3 terms. We have negative 4 times t times binomial. But we're going to go ahead, group these 2 factors and make it look like it was 1. So product equals 0, then one of these factors has to equal 0. Either this first product equals 0, or this other product equals 0. This other factor equals 0. If the first factor equals 0, let's go ahead, divide both sides by negative 4, and that will give us t equals 0. If the second factor equals 0, let's go ahead, isolate the variable term by adding 333 to both sides, and that will leave us with 4t equals 333. We keep our cool after we divide both sides by 4. Then that will give us t equals 333 over 4. So this is a fraction. It can't be reduced. And check it out. So if I asked you on the street, hey, how long is it going to take for the object to hit the ground? And you're like, oh, I got you. It's going to take me 333/4 of a second. I'll be like, whoa, why don't you talk to me in English? Okay. So don't leave your answer as an improper fraction is what I want to get. Is what I want to get at for the word problems. So you have options. Option 1, write it as a mixed number, or option 2, write it in decimal form. I'm going to go ahead, use my calculator to write it as a decimal. If it gives me a nice clean decimal, then I'm going to do that. If it gives me a funny decimal, then I'll write it as an improper fraction. Okay, but according to our calculator, we get a nice clean decimal. We don't have like a repeating decimal. Okay, or something that has like 20 decimal digits. Okay, so I'm at a crossroads. So the question says, how long does it take for the object to hit the ground? Okay, so we have 2 answers. The time could be 0 and the time could be 83.25. Now, if I throw something in the air and I ask you how long is it going to take for hit back to the ground, I'm like, oh man, is it going to take me 0 seconds or is it going to take me 83.25? Let me tell you why we have 2 solutions. The first answer, t equals 0. T equals 0, that means that like the time hasn't passed, so the object hasn't left the ground. Okay, but actually after we toss it in the air, it's gonna take exactly 83.25 seconds to hit the ground. So we don't have to write our answer in a sentence, but that never exempts us from excluding the units. Students like to put the unit here, right here, but this is that's not really good, okay? Because when you have an equation, I need you to solve it. So I need to see variable equals, then in a new line, write what you have to write, okay? So we're gonna ignore the first one, the first solution, because t equals 0 is when the object has yet to leave the ground, okay? But after we toss it in the air, it's gonna take exactly 83.25 seconds to hit the ground. Let's go ahead and knock out problem B. So problem B reads, what is the height of the object 10 seconds after it is projected? And then we don't have to write our answer in a complete sentence unless we really want to. Okay, so what is the height of the object 10 seconds after it is projected? No idea how to attack this, okay? So I'm going to try to break it down. I'm going to highlight what is given and then what we are asked to find. What is the height? So I'm like, height equals, I have no idea. Height, which is given by the function, equals no idea. Question mark. What is the height of the object 10 seconds after it is projected? So they give us time. So time, which is given by t, equals 10 seconds. Okay. So what is the height of the object 10 seconds after it is projected? Okay. It could probably be still in the air. It could probably be coming down or whatever. You're awesome, but I'm not. So I'm going to start out with the function that gives us the height. So according to the problem, we have h of t equals negative 16t squared plus 1332. Oh, 1332t. Okay, so plug in what you have, find what you need. We're gonna plug in a 10 for t and then solve for h. Okay, plug in a 10 for t, so we have h of t, which we substitute with the 10. And since we keep the function notation, pretty much we want to find h when the input equals 10. In English, substitute a 10 for t wherever you see it, and then you're good. Okay, so that will leave us with negative 16 times t, which is 10 squared, plus 1332 times t. I know I'm supposed to read it as 1332, but 1332 just rolls off the tongue. This is not an arithmetic course, okay? So at this point we just have like this expression that we're gonna go ahead use our calculator, okay? We're gonna go ahead punch it in, but if you don't have access to a calculator, then you're gonna freehand it, okay? Order of operations and all that good stuff. Okay, so we have negative 16 times 10 squared, and if you can't access your exponent button, then just put 10 times 10, okay? Plus 1332 times 10, and according to the calculator that gives us 11720 or 11,720. So that is the answer. We don't have to write the answer in a sentence, but that doesn't exclude us from including the units. The question is, what is the height of the object 10 seconds after it is projected? Well, the height 10 seconds later is that, and the units on height is feet, I believe. Okay, why? The problem said feet. So where am I? Just in case you don't trust me. Okay, we had said that h of t represents the height in feet. Fantastic. So today I said we were going to do 2 problems. This is our first problem. Let's go ahead and knock out our second and final problem. Okay, so fun problem number 2 reads, a ball is projected upward from the ground. The height h of t of the object in feet at time t in seconds is given by, you can read. H of t equals all that good stuff. I'm not even going to read the problem right now. This is just the prompt. So again, I need to have a clear idea of what t and what function h represents. If we don't have that clearly delineated, whether we write it or not, there's no way we can attack this problem. So let's go ahead and do this. So from the top, a ball is projected upward from the ground. So I lost my Play-Doh, so I'll just use my pen. We have a ball, it's projected upward from the ground. So it's right here, we toss it, and then it comes back. Okay, the height h of t of the object in feet. So once again, h represents the height and the units are in feet. So we have h of t equals height and the units are in feet. At time t in seconds, so t represents time and the units are in seconds. Okay, so now that we have that delineated, oh, what does T represent? Oh, it's just the time in seconds. What does H represent? Oh, it's just the height in feet. Now that we have that clearly delineated, we're good. So the question reads, at what times will the ball be 240 feet from the ground? And for some weird reason, we have to write our answer in a complete sentence. At what times? I don't know. So I'm going to have time. I'm like, oh man, is time my T or my H? Time is T. Time equals question mark. Okay? That's how I paraphrase things. You don't need a paraphrase? Then don't. Okay? At what times will the ball be 240 feet from the ground? So in this case, the height, which is given by H of T, will be 240 feet. Okay, so let's go ahead and do this. So I'm going to start off with my function again. So we have H of T equals negative 16t squared plus 128t. If they give me an equation, I start out with the equation. If they give me a function, then I start out with the function. So I'm going to plug in what we know and then solve for what we need. We know that the height is 240. So we're going to represent height with 240. And then we bring down the rest of the problem and then solve for what we need. Okay, so in this case, we're going to go ahead solve for T. So I'm like, okay, what kind of equation is this? Is it a linear equation? Is it a quadratic equation? In this case, once again, we have a degree 2 equation or a quadratic equation. So we're going to solve it by factoring. In order for us to solve by factoring, prerequisite step is to watch out for common factor. Prerequisite step is to set the equation equal to 0. I don't really care where the 0 stands, left side or right side. So I know that the guideline says fix it so the leading coefficient is positive. But check it out. If we just move the 240, then the equation is set equal to 0 right away. So that's my take. Let's go ahead and set the equation equal to 0. Again, I don't really care if the 0 is on the left or the right. Signs will cancel either way and we'll get the same exact answer, I promise. Alright, so let's do this. When we solve an equation by factoring, our first step is to set the equation equal to 0. Our second step is to factor completely. Now, when it comes to factoring, prerequisite step is to watch out for common factors. I'm not quite sure what the greatest common factor is, so I'm going to go ahead and use the ladder. So we have 16, 128, and 240, and we're going to divide by the first number that comes to mind. Again, these numbers are out of my zone, so I'm just going to divide by 2 a bunch of times unless I see like a larger factor. If we divide by 2, 2 goes into 16 8 times, into 128 6 4 times, and to 240 120 times. Sorry, I was trying to do the division. They're still even, so I'm going to divide by 2 again, and that will leave us with 4 32 and 60, okay, or 32 and 60. I was gonna divide by 2 again. Actually, yeah, because I'm not even sure if 4 goes into 60. It's gonna take me a lot longer to try to figure it out versus divide by 2. I love dividing by 2. I feel like such a genius. I just have everything. 2 goes into 4 2 times, into 32 16 times, and into 60 30 times. And look, we can continue to divide by 2 once again. The smaller the factor that you use, the more steps that you will have. The larger the factor that you use, the fewer steps that you have. But remember, the most important thing is that for you to start to divide now. If you sit there for 5 minutes trying to be like, what's the biggest factor? You would have done this a lot faster if you just divided by the first factor that comes to mind. Okay, so I digress. So let's see what we're left with when we divide by 2. So that will leave us with 1, 8, and 15. Our leftovers don't have any factors in common other than 1, so we're good with the ladder. The GCF is given by the product of all the numbers to the left of the ladder, and if my eyes don't fail me, I believe that the product of 2, 2, 2, 2 gives us 16. Okay, so coming to our problem, thanks to our hard work, the greatest common factor is a 16. There's no T. And we want to start on a positive note, so we're going to factor out a negative 16. When we factor out a negative 16, let me just bring down the equal 0. When we factor out a negative 16, that will leave us with t squared minus 8t plus 15. So I pointed to the side, sorry, because I forget that you can't read my mind. 128 divided by 16, I can't do that off the top of my head. But if you did the latter, 128 divided by 16 gives you 8. Cool. 240 divided by 16, I can't do that off the top of my head. So you have options. Option 1, punch it in, or option 2, just like use the work that you wrote, if any. 240 divided by 16 gives us 15. So this is why I pointed to my letter. Okay. So to solve a quadratic equation or degree 2 equation by factoring, first things first, set the equation equal to 0 and then factor completely. We have begun to factor, but not quite yet completely. If the degree is 2, then I'm going to assume that we can keep on factoring until we realize that we cannot, okay? But I love this trinomial. Why? I love it because the leading coefficient is 1, so I don't have to use the Macy method unless you really want to. So let's go ahead, throw down parentheses, focus on getting the product of the first terms. Product of the first terms should give us t squared, and we're going to use variable times itself. To complete the binomial factors, we want factors of c that add up to b. So factors of 15 that add up to negative 8. I think it's 5 and 3. Where both 5 and 3 are negative. Okay. If you want the x game, then go ahead. But if you don't need it, then I don't need it. Okay. So remember, leading coefficient is 1. So we want factors of c that add up to b. Factors of 15 that add up to negative 8. And that's negative 5 and negative 3. And then you use the sides to complete the binomial factors. Again, you can switch the sides. If you switch the sides in the x game, then your binomials will be flipped, and it's okay. Let's bring down the rest of the problem. Times negative 16 equals 0. Alright, so let's go ahead and do this. So how do we solve a quadratic equation by factoring? Step number 1, set the equation equal to 0. Step number 2, factor completely. Step number 3, apply the zero factor property. So if a product equals 0, there's no way around it. One of these 3 factors has to equal 0. Either the first, second, or third factor equals 0. If the first factor equals 0, that's a lie. Negative 16 doesn't equal 0, so we're just going to ignore it. So either the first factor equals 0, just kidding, or the second factor equals 0. Let's go ahead and write it out. Or the third factor equals 0. So either that t minus 3 equals 0, but something has to equal 0. Sorry, one of the factors, okay, not the solutions. If t minus 5 equals 0, after we add 5 to both sides, that will give us t equals 5. If that third factor equals 0, once we add 3 to both sides, that will give us t equals 3. Okay, so the solutions are 5 and 3. But now let's go ahead. Let me go ahead and read the problem. Okay, we did the algebra, but sometimes I get so caught up in the algebra that I forget the question. So the question reads, at what times will the ball be 240 feet from the ground? So the time is denoted by t. At what times will the ball be 240 feet from the ground? So we have 2 answers. Unlike the other problem, we're not going to discard them. Okay, so I'm like, oh, which one is the answer? Both. So first I have like the ball. I guess when it goes up, 3 seconds later, it's at 240 feet. It keeps going up, and then what do they say? What goes up must come down. When it starts to come back down, it's going to hit that 240 feet mark, and that will be 5 seconds thereafter, well, from the start. Okay, so phrase your sentence however you want. I just need to make sure you have a 3 seconds and a 5 seconds in there. The question reads, at what times will the ball be 240 feet from the ground? This is how I'm going to phrase it. The ball will be 240 feet from the ground in 3 seconds and in 5 seconds. Okay. So the ball will be 240 feet from the ground in 3 seconds and also in 5 seconds. So phrase your sentence however you like. Just make sure you include a 3 of 5 and include the units. Okay guys, so I promised you 2 sets of fun problems. That's our second fun problem, so I'm out. Gracias. That means thanks.